Blimey, that's loud. Good morning. Everyone all right today? Hands up if you've got a hangover. Well, you, obviously, yeah. So, welcome to Build Your Own Azure, which is, honestly, no, we're not going to build Azure, because Azure is really, it's big, it's complicated. It's got databases and document databases and storage systems and InfiniBand ultra-flat mesh networking and media services and whatever else. We're just going to build a very small part of Azure. There's a thing in Azure now, and in most clouds, actually, but in Azure it's called App Services. It was called Web Apps, and it's basically a part of Azure where you can just build an application and then just push it into Azure and run it. This was a trend. It was started by Heroku, I think, were the first people who do it. You basically did a git push Heroku master, and it just automatically built all your code and ran it for you. So I'm going to show you how to build your own app services. The original plan was that I was going to bring in a little server rack that was about that big. And I tried it with Raspberry Pi, but it didn't work. And then I was going to import a bunch of Kangaroo mini PCs from the States, but that would have cost me nearly £1,000 for a talk, and no. So I'm going to build my own Azure, and I'm going to run it in Azure. Because I know what I'm doing with Azure, I understand it. But I'm going to run it cheaply and cost-effectively. So why would you want to do this? Well, this is the primary reason. If you use app services, all that convenience and lovely stuff that they've built on top of the underlying infrastructure comes at a premium cost. And it's a big premium. An app service VM costs £55 a month, and the same size of VM running Ubuntu 16.04 costs £36 a month. And that's for the kind of dual-core D-series VMs. And £36 a month gets you quite a nice box for running Linux, but it's not a great box for running Windows and IIS and all the stuff that goes on top of that. So you also get more performance out of that £36 a month than you do out of the £55 a month. So that's one reason, and multiply that up by the number of cores you actually need to run all your apps and services and everything else, and that becomes a fairly substantial amount of money. I know because I used to run an app that was in every Azure data center, and I was running it on app services, and when my BizSpark Plus ran out, I nearly went bankrupt, honestly. That's why this laptop is so old. I'm still recovering from app services. But the other reason that you might want to do this is just the control. So when you run app services, they basically go, it's a VM, and they don't tell you what kind of VM it is. So you don't know whether it's an A series or a D series, what kind of storage it's got, whether it's using SSDs or the old kind of spinning Rust, whether it's using premium storage with the really fast disk access underneath or anything else. And there's basically, you've got 1 core, 2 cores, 4 cores, or 8 cores, that's it. And so if you switch over to VMs, then you've got all the available options, the massive compute things and everything else, and you can run whatever you want, and you can spec them according to your requirements. So that's kind of also a very good reason to build your own app services on top of this thing, even though I am just running it in Azure. I'm building my own Azure inside Azure. It's like Googling Google. It's going to make the internet explode. So what are we actually going to build? What we want is something with easy deployment, so I can build an application and then just deploy it without really thinking about it, automatically handle domain assignments and routing and everything else that goes on there. And because this is 2017, we want HTTPS on everything by default. So we're going to build all of that in an hour. Actually, in 55 minutes, because that's what I've got left, because I talk too much. So, step one. There are not going to be a lot of live demos in this, because there's an awful lot of moving parts, and it works eventually, but you kind of have to restart scripts and things occasionally. And also, Niall is in the room, and he's got an internet disruptor, and so I don't want to depend too much on the internet, just in case he decides it would be funny to break me. So, runtime. We're going to use Docker, obviously. This is now your opportunity to get up and walk out of the room if you are really sick to the back teeth of hearing about Docker. No, it's a DevOps talk, so, Docker. We're going to use Docker Swarm, and Docker Swarm is the new thing in the current version of Docker 1.12. They added Swarm mode into the core system, so you can spin up a bunch of machines, run Docker on them, tell some of them that they're managers and some of them that they're workers, and then just say, create a service and run it for me, and it handles everything in there. And you can do this from the command line, or you can use kind of GUI tools. There's Docker's universal control plane. If you're running in Azure, there's Docker for Azure. If you're running in AWS, there's Docker for AWS. I would be very surprised if there's not a Docker for Google Cloud at some point. So that's what we're going to set up. And the infrastructure that we need to run this on in Azure terms, so we need some servers, obviously, and we need those servers to be in a network. And for disaster recovery and availability and load balancing, we need them to be in an availability set, and then we need a load balancer in front of them pointing at those different machines and doing the routing. The servers, we're going to create one manager and two workers. So the manager is the thing that controls the cluster and tells the workers what to do and works out that that worker's not doing very much and that worker's overloaded, so I'm going to move that service from there to there and just auto-balancing and everything else. We're going to run this on Ubuntu 16.04 LTS because why would you run any other Linux? But it doesn't matter. You can run it on anything. That's the nice thing about Docker is you get a machine, if it can run Docker, then it can run pretty much anything. And Ubuntu just happens to be the one, their package manager. I know what I'm talking about. I know what all the libs are called and everything else, but you can use Fedora, CentOS, Red Hat Enterprise Linux if you work in the financial sector, where they actually won't use something if they're not allowed to pay for it. I love the financial sector. And you can use Oracle Linux if you hate yourself and you want to die. They're not a sponsor, are they?
Not anymore.
No, not anymore. So, to set up a manager, you spin up your box in Azure with, this is assuming Ubuntu, and then you do that first line there. Hands up who thinks that first line there is the worst line of anything they've ever seen anywhere ever. Yeah. Download something off the internet and pipe it straight into SH, preferably with sudo. So yes, I say it's okay because it's HTTPS, and so I know it's coming from... What you would actually do, though, is you would download that shell script and you would go through it and make sure it was doing what you thought it was doing, and then you would just run it with SH. But this is easier, and I like telling people to do this because it creates millions of machines running in clouds all around the world that are vulnerable to my botnet. So that I can infect Mongo and Elasticsearch clusters and then hold them to ransom and tell them that if they give me Bitcoin, I will give them their data back. No, I've just deleted it. So yes. That's assuming that they get my message and Niall hasn't come along since then and dropped in his message telling them to give him Bitcoin. Then I'm going to, that second line there is really handy. When you've installed Docker, you add your login to the Docker group, and then you kind of need to log out and log back in again usually. But that means you don't need to use sudo to communicate with the Docker daemon anymore. And then to create the manager, we just say Docker swarm init, and then the advertise address is your internal IP address on your network, so 10.0. whatever. And then we're going to secure it, because seriously, I got a call from one of my consulty-type customers saying, have you ever heard of a container called runner's root? Did you put that on our system? And I'm like, no, that wasn't me. They hadn't secured their swarm, so anybody could just deploy anything they wanted on it. And there is a Docker container called run as root, which allows you to do root things on the host operating system. And the thing is, Docker, when it's listening on TCP, it listens on port 2375. And there aren't that many IP addresses, and machines are very fast these days. And so if you've got a botnet, you can just scan all the IP addresses in the world and see if there's something listening on port 2375. And if there is, you can go, can I run Docker things on that? Ooh, yes, I can. So secure your swarm. It's not actually that complicated. All you have to do is create your own certificate authority, and it's not complicated. So, like Komodo or Let's Encrypt or whatever, you just create your own certificate authority. Then you create and sign a certificate and use that on the server to secure that. And then you create client certificates, and any client certificate that is signed by the same authority as the server certificate will be able to communicate with that server. Okay, so that sounds really complicated, but actually this is how you create a certificate authority. It's 2 lines of code. You generate a key and a public key and a signing thing. And what I don't understand, I just type the words in and stuff happens and it seems to work. But that's how you create a certificate authority. So the things that are coming out of this, basically your ca-key.pem and your ca.pem, check those into GitHub because as long as you put it in a private repository, it's fine. How is anybody going to be able to access it if it's in a private repo? I swear to God, I'm going to strangle some of my customers. That's how we create a certificate authority. Then this is how we create a server certificate, and that's basically, so we generate a key, and then we add a subject to it, which needs our domain name in there. So I've already got my stuff up and running on Azure. It's running on spiffymanager.northeurope.cloudapp.azure.com. I'm going to add in the internal IP addresses it's running on so that other things inside can talk to it as well. And then that last bit there is just how you sign your certificate. This bit here, I could have done this with the mouse, couldn't I? Whatever. That's my password. That's the password I use for everything. So you can access pretty much anything of mine on the internet just with the password secret squirrel with numbers instead of letters. Does anyone remember Secret Squirrel? Old people. It was the best. I've just made up a cartoon that I'm trying to convince my children was real called Captain Spang and the Mumply Bumplies. And I'm trying to seed the internet with evidence that this was a thing. The Mumply Bumplies were always stealing Captain Spang's cheese. So yes, and generating the client certificate, it's pretty much the same thing, except instead of the domain name, we just put cn equals client, and that goes into files on your system, and then you copy those into your .docker directory in your home directory, and then Docker will use those to communicate with the remote server. To add the you can get all this off the slides. The slides are public, and theoretically, by the end of the talk, there will be a website that you can go to that's got links to the slides and to all this code on GitHub as well, as long as the demo works at the end. Okay, so then we just configure Docker to tell it to listen on the TCP. So Docker, by default, listens on a Unix socket, which is just a file. We're going to add some stuff to the startup here to say, I want you to listen on TCP. I want you to use transport level security. Here's your key. Here's your certificate. And here's the address I want you to listen on, which is just the network host. And when Docker's running securely, it runs on port 2376. So it's not worth your botnet trying to connect on 2376 because it's going to be secure. So we do that, and then we just restart Docker so it's secure. And then on our kind of machine that we're doing stuff on, our client, our desktop machine, to attach to the swarm, we say export Docker host equal, create an environment variable in Windows, however you do that. Export Docker host equals TCP : / and then the web address of our manager. TLS verify equals 1 just tells it to use TLS certificate authentication. And then talking to our manager, we say Docker swarm join token -q just says don't put all the other stuff out, just give me the token. And I want a join token for a worker. We can then use that token, which is a hash of something somewhere, no idea what, to tell the workers. So you SSH into your worker machines and just do sudo docker swarm join -- token and the IP address, and it will become part of your swarm. Okay? Everyone get that? Good. There will be questions in the pub quiz this evening. I've got a whole section on how do you do this in Docker. It's going to be a fun quiz. So, the next thing you need is a registry. A registry is where you put your Docker images. And there are multiple options here. The simplest one, and the one that I advise people to do just for small projects and for making life easy on yourself, is you can just pay a small amount of money for a private repo on the Docker Hub. They will host your image for you and keep it private and safe. That's fine for a lot of things. If you've got like proper security concerns, like you're a bank or scary data type stuff, then don't do that because it is public and they might get hacked. They probably won't, but they might. So the other option, or one other option, is to use your cloud providers registry. So Azure and Amazon and Google all provide Docker registries built into the system, and so you can push your images into there. Or you can just run your own Docker registry. Guess which one we're going to do? Haha. It's actually really, really easy. All you have to do is run the registry, and then you have to secure the registry for the same reason you have to secure the swarm, because otherwise people can go, oh, that looks like a nice image, I'll just replace it with one of mine. So I'm going to use Docker Compose for this. If you are using Docker and you are not using Docker Compose, you are an idiot, and you should stop and just go and learn Docker Compose. It's rather than running Docker commands with all those -- this and -- the other and -- whatever else, you create a YAML file and you put all the things you want to run in it and all the parameters and configuration and everything, and then you just say Docker Compose up, and it starts it running. And you can spin up 15 different services and multiple networks and volumes and all sorts of stuff. It's great. So this is the Docker Compose for starting a registry. Restart always says to the Docker daemon, if this crashes, can you start it again, please? Cheers. And then the Docker registry is available as a Docker image from Docker. So you want to run a registry, you go Docker run registry. And we're using version 2. We're exposing a couple of ports, 5000 for unsecured access and 443 for secured access. And then we're mounting some volumes onto it. So we're mounting our own configuration file in there, and we've got an authentication folder which has got something in it that we'll look at, and we've got our cache folder as well, which is where it could potentially keep the actual image data. This one's a bit more scary. This is the configuration file, but it's not difficult to write. What you do is you go to docker.com, you find the page with this on it, and then you copy and paste it into a file on your machine. And then you delete the bits that you don't want. That's how the professionals do it anyway. So this is a Docker registry configuration file. Important lines. So we are going to use Azure storage, because we're running in Azure. We're just going to use blob storage to store our image data and push it and pull it and everything else. And then we're going to tell it what to do on HTTP. And because we want this running on HTTPS, we are going to use Let's Encrypt to grab a certificate and apply it to the registry. And the Docker registry image has support for this built in. So you start it, and because it's in the configuration, it goes to Let's Encrypt and says, give me a certificate. And Let's Encrypt says, are you the domain you say you are on the IP address? Why are you smiling at me in that way? Oh. It is. It just does it. It's fantastic. This is the alternative to applying for a certificate from GoDaddy or Komodo or whatever, and then waiting 24 hours while they verify that your Gmail address is actually you. So yes, and then we're going to. So that's what the cache directory is for. Le cache, obviously, that's let's encrypt cache, and the email address there. That's going to become the certificates contact thing. So if anyone wants to get in touch with me to find out who I am and what the hell I think I'm doing, they will be able to. And then, so we've got storage driver, and then the HT password down at the bottom bit there. We're just using basic authentication for this because that's easy, but you can also set this up to use the same kind of certificate-based authentication that you use for the Swarm security. So, basic authentication. One of the things I really love about Docker is it's not just for spinning up services and running them and leaving them running and so forth. There are really complicated kind of commands or things, and you would have to install an absolute shed load of stuff on your system to get it to work properly. And so you can use Docker containers just as command line things. And the registry container actually will allow you to run it and use its built-in HT password thing to create your encrypted password file. So we create a directory called auth in the same directory as our Docker Compose file. And then we Docker run, tell it to run HT password as the entry point instead of what it normally does. And then just pass in those parameters there. So this is Mark, that's my password again, and that's going to go into an HT password file on my local system, which is then going to get mounted into the Docker registry when I run that. Okay? So I do that, then I do Docker Compose up, I do -D to tell it to run in detached mode, so it just carries on going, and then I log out of the machine and I have a secure Docker registry that I can access over the internet. Okay? It's incredibly easy and straightforward. How long do you think all this is going to take when you do this? Like, what, half an hour, maybe an hour to run these commands and so forth? So that's all very well and good, but it gets boring. It gets boring really quickly. Did anyone go to James Nugent's talk on Terraform and Console yesterday? No? There's some people. Terraform is awesome. Essentially, all you're doing here with all this sort of modern, cloudy, DevOpsy type of thing is you're entering commands into a console and waiting until they finish and then entering another command in. Or, you know, if you are more of a GUI kind of person, you're navigating the lovely Blade system in the Azure portal and ticking tick boxes and putting settings in there and uploading files and everything else. And Terraform basically does all that stuff for you. It's a system for scripting infrastructure. And you tell it what state you want your infrastructure to be in, and then you do an apply, and it just goes and does it for you. And it's really powerful, and it will work with all the different clouds and DigitalOcean and various other things as well, and it also works with ancillary providers and so forth. So I'm going to show you a couple of Terraform files here. I'm going to close all of those. I'm going to Control+. So here's Terraform. Here's the registry. So this is a Terraform script file, and all this is going to do is it's going to buzz through all my various commands here, and I just tell it what I want to exist. And then when I run it, it goes off and it looks, and for anything that doesn't exist, it will create it. And so I say, I want a resource group called Spiffy Registry, and I want a virtual network, and I want a subnet within that virtual network, and then I need a public IP address, and I want that to be static. And then I need a network interface that I can attach to my virtual machine. And then I need some security rules to say what ports are allowed in. So I want 80 and 443 and 5000. And I might want to SSH into it, so I'm going to open port 22 as well. And then I need a storage account, which is where all the images and also my disk images and so forth are going to go. So I'm going to create a container in there called VHDs. And then I'm going to create my virtual machine. And so this is the fun bit. You say, this is the image I want to use to create the virtual machine. So it's canonical Ubuntu server 16.04.0-LTS. Use the latest version of that. Create an operating system disk. Create a login. Disable password authentication and upload my local RSA key so I can SSH into this machine without passwords. And I will log in as that user there. I want to tag it with a production tag to say this is a production system, even though it's not, it's a demo. And then, when I get to the bottom here, I'm going to say remote exec and tell it to log in using the Spiffy admin user and then run that get docker and pipe it to sh and then add the thing in there. And then I am going to add in the steps to just run the registry and create stuff and everything as well. Again, what you would do if you were concerned about security is you would download that shell script and add it to the resources within your Terraform directory, and then you can just upload that script from your local machine and then execute it on the remote machine. And that works perfectly well as well. And then, so at this point, a lot of people say, what do you think of Azure Resource Manager? So Azure Resource Manager is essentially Terraform-ish, but it's just for Azure. And there are two things that turn me off Azure Resource Manager. I love the fact that it exists. It's only because Azure Resource Manager exists that Terraform can do what it does, because Terraform is using it under the covers. But they have this thing called ARM templates, which are JSON files that do roughly the same thing, except JSON, it's not a scripting language. It's a serialization format, and I wish people would just get over JSON as a scripting language. Just stop it. Maybe for configuration, maybe for sort of like a couple of settings and whatever else, it's fine. Or if you've got something that handles it for you automatically, like NPM, then that's fine too, because NPM's Java works with JSON, fine. But so that's one issue with it. And the other thing is that for some reason that I cannot fathom, Azure Resource Manager templates don't work with AWS or Google or Cloudflare. And Terraform works with Cloudflare. So I have a key, a token, so I can talk to Cloudflare. So at the end, when all this is up and running, Terraform will also attach to the Cloudflare API and set up a registry subdomain on my spiffydemo.com domain that I registered just for this talk. £8 that cost. And it'll create that record. And so once this finishes, I then have my Docker thing running, and it is actually addressable from the internet. So that's quite a fun script. And again, that's going to be in the resources that there'll be a link to at the end of the talk. Here's an even more fun one. So this does actually create the entire swarm, and it secures it, and it gets it up and running. And once this is done, it's done. And it's not actually that much more complicated. So essentially the same things go through here. Quick note about variables. So all your tokens and your hashes and API keys and everything else that you need to operate Azure Resource Manager or Cloudflare's API or whatever else you're working with. I don't care if your repository is private. Do not check credentials into GitHub at all, ever. Don't do it, all right? Just stop. Has anyone ever done that on purpose? Just gone, it's fine, it's a private repo. No one's going to admit to it now, Mark. You've scared the shit out of them. Except that one guy there, he's big. All right, big guy? Don't turn around and look at him, you'll embarrass the poor bastard. Right, so yeah, the secure variables are all in a tf-vars file, and you just add star.tf-vars to your git ignore, and that stops it from ever going in there. So, and I just declare those variables up at the top here, and then I've got other variables that I'm declaring, and I'm putting defaults in because it's fine. People can know that this is running in the North Europe data center. They can know I'm running standard D1 V2s. It's all good. I'm not scared of those things. So my Cloudflare email and token and domain are also across in there as well. Right. So we now have our same sort of thing, virtual network, subnets, bunch of public IP addresses. We're creating a load balancer in this one, so we need an IP address for the load balancer as well. And then we've got back-end address pool is just this is what you're going to use as your routing system. 3 network interfaces. So we've got our manager here, which is being set up one way, and then we're creating workers, and the workers are all identical. So we just declare it once, and then we tell it how many of those things we want to create. For a production system, incidentally, you would be looking at creating 3 managers and then as many workers as you need. And the workers don't have to be the same. You can create different kinds of workers for running different workloads with completely different configurations, and then you can tag them, and then when you start services, you can say to Docker Swarm, I need you to run this only on workers with this tag. So if you've got stuff that's doing really complicated compute, then you can spin up 36 cores and half a terabyte of RAM and so on, and then tell the big compute tasks to run on those, but all the website stuff can just run on little D1 V2s or whatever. If you're running D1s, by the way, stop, switch to the V2s. They're cheaper and they're much faster. So yeah, Azure tips. So network interface on the workers, security group, inbound rules, we've just got 80.443, 2376 for the manager, so that we can control it remotely. SSH, as usual, and then similar sort of stuff. We've got storage things. We're creating an availability set because we're going to put each of these machines into the availability set, and then that allows us to have a load balancer that points to all 3 of them. If you don't have an availability set, the load balancer will just go, no, not talking to that. And what the availability set does is it makes sure that each of your machines is in a separate cargo container in the Azure data center. So if one of them explodes, your whole system doesn't come down. Then we create our manager virtual machine, which is pretty much the same as the things before, except down at the bottom here, we're going to run generate cert.sh, which is going to do that whole create a certificate and sign it for us, and put that into a file. Then we're going to upload our Docker config directory up onto the remote machine. Then we're going to attach to the remote machine using SSH. And we're going to run all the security, still piping the thing through a shell script, create the swarm, and then run that configure docker.sh, which is going to secure it and everything else. And then, on the local machine, we're going to run a script called getToken.sh. None of these are going to work on Windows, by the way, so I hope you're all running either Mac or Linux as your primary desktop operating system. They would be fairly straightforward to convert to CMD files. Yes. Yeah, I have issues getting Bash on Windows to talk to the Docker for Windows host for some reason. And the Bash subsystem for Windows, absolute bad words when it comes to Docker. It tries to run Docker. And it can't run Docker because it's not actually Linux underneath. And also, it will. I actually believe that once they get the whole Windows subsystem for Linux and Bash on Windows working, and Ubuntu on Windows working, I think we'll be able to run Docker inside it, because the stuff you can already do is just amazing. Yes. Funnily enough, you can't run the Linux version of .NET Core on Bash on Windows or Linux on Windows yet. But again, you will be able to. Just run Linux. When I get my new laptop in March, which is going to be probably insanely powerful kind of 4-core thing, People think I run Linux. I tell people I run Linux if they're if they're accusing me of being a hipster, because no. I say, oh no, it's because the machine's so old and Windows just runs like a dog on it. But actually, I've been doing it for 2 years. I kind of like it. It's nice. So yeah, I am just going to put Linux on whatever I get and then run Windows in a virtual machine for demos. So this is creating the workers. So what that this script here basically sets those things, sets the Docker host and the Docker TLS verify, and then gets the token and dumps it into a file on my local machine. Then when the swarm worker things are being created, I can use that token while they're starting up, and I can just copy the token up into the temp directory there, and then do the Docker config thing, and then say Docker swarm join and pass the token up as well. So this Terraform script creates a manager, gets the token, and then creates the workers, and then joins them to the swarm as well. So by the time this thing is finished, you have an up and running swarm. And then we've got some load balancer stuff down there, just saying do HTTP and HTTPS, and a probe, which is just literally going to say, can I attach to this machine using SSH? Or can I attach to this machine on port 22? And if I can, good. So if the SSH daemon is running, it will consider the machine healthy. You would want a more realistic health check for that in reality. And then down at the bottom here, we've got a couple of Cloudflare records that we're creating. A wildcard, because Cloudflare will do wildcard DNS records. It won't do all the Cloudflare magic on them, but it will at least do the DNS. So anything at anything.spiffydemo.com will now get routed to this cluster unless there's a specific record for it. And I'm also going to create a record for the root domain, which is just to do with Let's Encrypt. If you don't have the root domain on the right IP address for some reason, Let's Encrypt doesn't like it. Okay? So when I have better internet and more confidence and everything, I just run both those scripts at this point. And they take about 10 minutes, both of them, to complete. About 3 or 4 minutes for the first one, and then the second one takes between 5 and 10 minutes, depending on how Azure's feeling that day. I'm not confident enough of the internet in the Excel to do that. So trust me, I ran this, and you can run it as well. You just download Terraform. It's a single executable written in Go by HashiCorp, and you put it on your machine, and then you just do Terraform plan, and it'll show you what it's going to do, and Terraform apply, and it'll do it, and then tell you what it's done. Down at the bottom here, I'm just getting it to output a couple of the variables that it's generated. FQDN is fully qualified domain name, so that's going to be spiffydemo.northeurope.cloudapp.azure.com. Okay. So now we've got a cluster running, and we can do Docker service create, and we can run things on it and everything else, but we still need a way to get it to serve websites really, really easily. That's kind of the point of this whole thing. I just want to be able to create a website and then just run it. So we need to serve web. And to do that, you want some kind of proxy running on this cluster that you can say, right, I'm going to spin up a service, and I want you to just automatically route requests based on the domain name, the header record, to the relevant service within here. There are 3 sort of major things that people use as proxies, and I have almost certainly missed a couple, and I have left IIS off on purpose. Nginx is the kind of one that always wins web server / proxy of the year. I love Nginx. You can script stuff in it with Lua, you can script stuff in it with JavaScript now, and you can run it in Docker and all this sort of stuff. There's also HA Proxy, which has similar characteristics. Nginx is also a web server. HA Proxy is primarily concerned with proxies and load balancing and health checking and everything else. And then there's Traefik, which is a new thing that's written in Go, and it's not quite as blazingly fast as Nginx because it's Go, and Nginx is written in really hardcore kernel level C. But Traefik does have a few nice characteristics. It has built-in support for an awful lot of stuff. And it has a gopher dressed as one of the guys at the airport, which I kind of like. I hate Go. I would never write Go code myself, but people do build some nice stuff with it. I'll give them that. If they put generics in, then I'm gone. I'm there. But yeah. So what does Traefik give us? Magical Docker integration. You can literally, when you start Traefik, you can say, you're running on a Docker swarm, and the manager is here. And just watch. And when something starts up, if I've applied certain labels to the service, then do your thing. And Traefik just sits there and goes, all right, I'm waiting. Yay. It's got Let's Encrypt built in, so you can just say, here's my email address. Please do Let's Encrypt for all the sites that I run. And the performance is acceptable. You would have to be hitting a lot of requests a second before Traefik became the bottleneck in your cluster. So it's perfectly decent. Much, much simpler to get it up and running than it is to get Nginx to do what I'm trying to do in this talk here. It's mature and supported enough that it has an official Docker library image. Basically, a Docker library image is one that doesn't have a namespace / prefix on it. So if it's just Traefik or registry or Nginx or anything like that, that means it's official, and Docker monitor it and approve it, and it has their seal of approval. Doesn't necessarily mean it works, but it means that Docker have checked it over and made sure that it's not malicious and so forth. So to deploy Traefik, we're now going to, we've got our environment variables set, so our local Docker command on our machine here is now controlling our manager in the swarm. If you've got multiple managers, you can connect to any of them. It's fine. They'll all just communicate and do raft consensus things. Always an odd number of managers, by the way, and probably never more than 5. 3 is the magic number for all these sort of Docker managers and Consul and Kafka and Zookeeper. Always 3. Once we set those, then we can just say Docker network create, and we're going to create an overlay network, which is a virtual network that Docker puts over the top of whatever the actual network is, so that the machines can talk to each other, and we're going to call that network Traefik. I did briefly experiment with pronouncing it with a sort of Afrikaans accent, but no, I will just get shot. I'll get Dylan in to do it for me or something. And then before I set up my Traefik server, like I said, the default behavior for Docker is to run on a network socket. And for some reason, if I point Traefik internally at one of the managers, it doesn't work. And so what I've got here is an image called socat-docker, or socat. And socat literally attaches to a Unix socket, so one of the file things, and proxies everything in and out over a TCP socket. And so I'm running that just so that my Docker proxy is running internally and is addressable over the overlay network. That's the issue with telling Traefik to attach directly to the manager, is the manager is not running as a service on the cluster. It's running the cluster, and so things can't talk out of the cluster. It's like trying to talk to God. He might be there, but he's not fucking listening. So we do that, and then we run Traefik. You only have to do this once, and then you're done, and it's fine. You just bang this in a shell script. So Docker service create, those first 5 -- lines are parameters to Docker service, and we're saying, so create service called Traefik, publish these ports, so it will listen on all those ports, attach it to the Traefik network. Mode global says run an instance of this on every node in the cluster. Okay, so you have options with this. You can say, I want it to only run on workers, I want it to only run on managers, I want at least this many instances of it running, but I don't care where they are, but I want this one running everywhere, so there are as many of it as possible. So that's going to go there. And then I'm just going to mount a temporary directory on the host machine into the container to store the certificates that I get from Let's Encrypt. Okay? This is quite an information-rich talk, isn't it? I've just kind of realized that. Yeah. Who would have thought that building your own Azure would be so complicated? It's just one of the, if Microsoft can do it, then... sorry. Mark Rasinovich can do it and write books at the same time. Just, what is that guy? They do seem to have some good people working for them. I'll give them that. Right, then Traefik colon latest is just the current Traefik image. And then everything underneath that is just arguments to the Traefik daemon. So we're saying you're running in Docker swarm mode, because it will support multiple ways of doing this in Docker, but swarm mode is the easiest. Here's your Docker endpoint that you need to listen to find out when services are being created and get information about them. Here's the base domain for all the things we're running in Docker, so spiffydemo.com. We'll look at what that's used for in a minute. Docker watch says watch Docker, and when something starts, maybe proxy it. And then entry points. This is one that I really like. You look at doing a redirect from like port, when something comes in on HTTP, doing an automatic redirect to HTTPS so that you always serve the site securely, and Google does good indexing and so forth. Do that in IIS, and you're installing URL rewrite modules, restarting your IIS server, and then writing half a dozen lines of impenetrable XML to get the damn thing to work. Here, you just say there's a TLS entry point, and there's also an HTTP entry point, but if anything comes in on that, redirect it to HTTPS. That single line does your whole redirect thing there. The default entry points, things can come in on HTTP or HTTPS, and then the Acme stuff, I don't know why it's Acme, but that's Let's Encrypt. Does anyone know why it's Acme? Is it just a Roadrunner thing? And you're like Wile E. Coyote going, ha-ha, my server is secure. They didn't think that through. It's because I wasn't in the meeting. But yes, that's just, so here's my email again, store the certificates in this file here, which I've mounted up at the top there, and get the certificate the first time a request comes in. That's what the acme.ondemand thing does. Is it? Thank you. Apparently it is automatic certificate management environment, and nothing to do with Roadrunner and Wile E. Coyote and catapults that kill you no matter where you stand. That is my favorite scene in any cartoon ever, where the catapult kills him 3 different ways. I just love that. Also, if you look on YouTube, you can now get the video where he catches the Roadrunner and eats him, which is just really good closure for anyone who grew up in the 1970s. It's awesome. So, now we're ready to go. Now we can just use our PaaS. So I've run both my Terraform scripts, and I've run my Traefik scripts. I've got a Traefik start.sh, and there's an le start.sh in the GitHub repository that will start the Traefik thing for you. So now we're ready to use our platform as a service. So the publish process to get a service up and running on our new cluster, you build the Docker image, and you push it to your private registry, and then you create the service, okay? And so this is how you publish it. You need to log into your registry, and then you need to build your Docker image and tag it with the registry name, and then push it to the registry, and then create the service with this line here, and then you will be able to browse to your thing. See, that's a very simple deploy process. It's still too difficult. That's far too complicated. I just want to run it, and so I wrote a thing, JFRI, just run it. It's pronounced Jeffrey because it's a thing, and I'm actually going to support it. I'm going to, and so this Jeffrey repository has got the Terraform scripts for spinning up the cluster, and it's got the shell script, but eventually it's going to actually have kind of Jeffrey create cluster will run the Terraform scripts for you, and it'll have Terraform as a dependency and so forth. So yeah, so you can get that. So I'm going to show you how that works. So I'm going to cd dot dot. I'm going to make this a bit bigger. Can everyone see that okay? Right, so I'm going to make a directory. I want to prove that this is working, so someone give me a name for my site. There's like NDC... NDC Roadrunner, okay. Yes, well, we'll be all right with the profanity filters on Cloudflare, so that should be okay. Right, so now I'm going to say .NET. Oh, just to prove how absolutely hardcore I really am, by the way, look at this. Yeah, I am running Preview 4 because I can. I like living on the edge. So I'm going to say .NET new type web. That's going to create me a web application. There you go. There's my web application. I'm going to say .NET restore so that I can work with it locally. Okay. I'm going to jump down to here. I'm going to run code dot to open it up in Visual Studio Code. Okay. I'm going to go into my views bit here and my home and my index. This is where Microsoft put all their marketing stuff. Bye-bye marketing stuff. We're going to grab these lines out of here instead. That's my marketing stuff. And we're going to paste that in there. We're just going to jump into the home controller. No, we're not going to jump into the layout. And in here, not now. And in layout here, we're going to change MVC app to NDC Roadrunner and change down to the bottom there. And I'm going to put my name in here. Okay, I'm going to save that. And I'm going to save that. And then this is the fun bit. Okay, that's not working. There we go. JFRI does need a couple of environment variables to be set for it to work. So this is building my Docker container. That's installing all my stuff locally there. I've got my own Docker base image, Rendle Labs/.NET, which includes, it's pre-installed and cached all of the web libraries and everything. So when I do a .NET restore in my child image, it doesn't have to go to the internet. That's a public image on the Docker registry, and you're welcome to use that or fork it from my GitHub repository and build it. That's running. Theoretically, now I'm going to go to the browser, and I'm going to go to ndcroadrunner.spiffydemo.com, and this is going to be running. Place your bets, ladies and gentlemen. And it's going to redirect me to HTTPS. And I'm going to close my eyes. It can take it... Well, you know, it's hit it because it did the HTTPS redirect thing. Sometimes it takes it a couple of tries to get the certificate back. Ah, you bastard. I swear to God, this worked just before I walked into this room. That's saying it's not private.
Mark, you connected to the network to proxy that through already? Remember, if you try go to a HTTP address only, and see to bring up the path port.
Sorry?
Go to a HTTP only address. So not only HTTP. Something like independent.ie.
Oops.
So that
Yeah.
Just that's not going to the props, it's going to the capture portal. The HTTPS should be able to work now.
Okay. It's not doing it. Why won't you do it? Okay. Docker service PS NDC road. Oh, that's interesting. Well, where did you just go? That would explain that. No, it doesn't explain where it's gone. Let's go over to this one. So it's running. And it's running okay. See, that works. That's the one I put up literally just before this talk, using exactly the same thing. That's working fine. And this one is not. So, yeah, I always like to finish my talks with a really abject case of demo fail. Docker service RM. I did, yes, yeah. This is exactly what Azure does. This is entirely right. Let's try dropping it and recreating it again. So we'll just run JFRI again, which is going to be much quicker because nothing's changed. I like that. Yeah, Joffrey. So that's done that. Let's give it another try. Oh, that's different. Nope. I'm going to debug this afterwards. I'm just going to try one more thing. MV NDC Roadrunner. Roadrunner. Run it one more time with a different thing, see if I get more luck. I was debugging this at 2 o'clock on Wednesday morning, trying to get it to work, and it turned out that Let's Encrypt was down or something. So roadrunner.spiffydemo.com. No, I'm going to debug this and find out why it doesn't work, but it will be there. Seriously. The other thing I can do for the time being is I can cd into labs NDC JFRI resources Traefik, and I can do Docker service RM Traefik, and then just do /start. This is the version that those are already running. Sorry? That's because I've just taken Traefik offline. So get rid of it again, and then start it again, and then just go to http://roadrunner. And now I'm getting bad gateway. Right. Start those again. 1 minute to go. Why? Oh, bloody. I'm going to fix this. But I'm not going to do it now. So yes, I will get that working, and then I will tweet the link to it. It's a good job I didn't do the thing where I went, I'm running my slides on this. So yeah. Eventually, you're going to want to sort of automate everything, and so look at building things like a build server. It's really easy to set up a build server for this because you don't have complicated libraries and everything. It's just Docker build, so you can use any of these to do that if you can figure out Jenkins, because the documentation is awful. The build steps are literally, you have a Git webhook, you clone it, you build it, you tag it, you push it, and then the registry sends another webhook, and you have something listening that automatically updates the service in the server. That's where you can get the resources. The slides are there. Jeffrey is there. I will get this bloody working. I'm going to go outside, and I'm going to do it, and it's just going to work. Yeah, exactly. That's just what happens. So yes, but feel free to contact me on rendlelabs.com. I'm doing consulting on all this stuff. If you want to do this at your business, I'll come and help you get it set up, .NET Core or whatever it is you want to run. Thanks very much, and I hope to see you at the end of the day when I'm doing another talk about what I'm going to be talking about in 10 years' time. Cheers, enjoy the rest of your day.